right, so I went ahead and wrote down the sections we're going to cover and the two main things that we're going to talk about today, just save a little bit of time here, okay? But it's the 17th, and we're going to take a look at section 9-2 and 9-5. All right, now I'm really hoping that last year you did a little bit of factoring, okay? Maybe not the entire chapter, it just depends on how things went with the variety of different teachers you had last year. So regardless, this chapter is set up to where they kind of teach it all together. They do a little bit of multiplying, and then they go to factoring, then they do adding, subtracting, then they do factoring. So they go back and forth. And if you've noticed, like the way I've been doing this, I didn't do that. I did all the add, subtract, multiply yesterday. All right, now we're just going to focus on the factoring because one undoes the other. If I multiply a bunch of polynomials, well, to undo that, I'm going to factor that. Okay, so I like to keep the two things separate initially, and then we'll start intermixing them later. So today we're just going to take a look at two main things. Okay, we're going to factor out a greatest common factor, and we're going to factor out factor our trinomial that has a leading coefficient of 1. Those are what we're going to look at. All right, now we're going to start with first this GCF. Okay, just from middle school concepts, greatest common factor, you should know, like I had to be able to give you two numbers like, say, here, I'll even write this down so we're not doing it so much orally. Just from like middle school math, I should be able to give you, say, a 24 and say a 36. And then I should be able to ask you to find the GCF, okay? So just in, what's the greatest common factor, all right? What's the biggest number that goes into both of those, okay? And that's going to be what, a 12? Okay, so answer is 12. All right, we're going to take that concept and we're going to use that concept on our coefficients. Okay, then we're also going to take a look at a greatest common factor pertaining to our variables. Okay, so concept's the same. Let's say I had an x squared and maybe say an x to the 5th. All right, and I want to know what the greatest common factor is. Okay, so find the GCF. All right, so the same thing I asked here, I asked myself, what's the biggest number that goes into 12, or what's the biggest number that goes into 24 and 36? All right, so what's the biggest factor? Well, all my factors are going to be x, right? So what's the biggest factor that goes into this and the biggest factor that goes into that? It's going to be x squared, okay? In other words, what could I take out? In other words, what's the biggest number I could take out of 24, the biggest number I could take out of 36 that matches? Same thing here. What's the biggest number of x's that I could take out of x squared? What's the biggest number of x's I could take out of x to the 5th? All right. Now, not that I really like just straight memorization type things or little tricks or mnemonics, but when I'm dealing with variables and exponents, this is a greatest common factor, right? So one way that you can remember it is it's going to be the smallest exponent. It's just going to be the opposite. Okay, just turns out that it happens to be the opposite. So every time, if I'm looking at two variables that have exponents, all right, and I want to know what the greatest common factor is, I'm going to pick the smallest exponent. So this would be an x to the 2nd. Okay, like I said, not a good conceptual understanding, all right, but it will get you a correct answer there. Now, what we're going to do, we're going to take this GCF and we're going to take a look at it as pertaining to our polynomials. Okay, and you need to kind of think of factoring out a greatest common factor as undoing the distributive property. Okay, so we'll start with just two terms. Okay, it's going to say, directions are going to say factor, or they may be a little bit more specific. They may say factor out the GCF. Okay, something like that. Let's suppose I had maybe say a 6a squared minus an 8a. All right, I can switch up those variables. I usually don't. I usually stick with x's, but it really doesn't make any difference. All right, so what I'm going to do is I'm going to take a look at this. I'm going to look at my coefficients. I'm going to find the greatest common factor of a 6 and an 8. Okay, hopefully we can do that really quick. As long as the numbers are small, we ought to be able to do this in our head pretty easily. That's going to be a 2. Okay, so I'm going to definitely take out a greatest common factor of 2. Then I'm going to take a look at my variables. And I'm going to say, okay, what's my greatest common factor between an a to the 2nd and an a to the 1st? All right, well, again, if you use that little trick over there, it's going to be just an a to the 1st or an a. All right, so my GCF, let's write that out separate here. My GCF for this problem is a 2a. Okay, and sometimes they might just say, find the GCF. All right, but now I want to, over here, let's put over here, we're actually factoring. Directions are actually going to say factor. So I'm going to take that GCF and I'm going to take it out. All right, now I had two terms originally. This is my GCF taken out. All right, I'm going to have, if I have two terms in my original thing, I'm going to have two terms here. Okay, so basically when I take it out, I'm undoing the distributive property. So if you stop and think about what we did yesterday, doing the distributive property, we were multiplying. So the opposite of multiplying is dividing. So out of each one of these terms, I'm going to divide out a 2a. So on this first term, 6 divided by 2 is going to give me a 3. All right, if I have 2 a's and I take one of them out, I have one left over. All right, that minus sign is just going to come straight down. Now I'm going to factor out the 2a out of the 8a term. So I'm going to do the same thing. I'm going to take that 8 and divide by 2. 8 divided by 2 is 4. If I have 1a right here and I pull it out, I don't have any left over. So then this is my factored answer. Okay, if I have two terms here, then I have to have two terms on the inside of my set of parentheses. If I have three terms here, I would have three terms on the inside. My GCF always goes out on the outside. All right, now somebody answer me, as so someone's gonna have to undo your mic. All right, did you do this last year?
I don't think we did.
Okay, all right, so that's good. That I need to know that so that I know how detailed I have to go here. Okay, now something that I don't want you to get confused. If the directions say factor, this is what you're gonna do. This is your answer. Now there is a way to check your answer and find out whether or not you just did that problem right. As with when we solve equations, I mean, not very many people do it, but when you solve an equation, if you take that answer you got, x equals 2, and you plug it back into that original equation, it should make it true. All right, so the same thing goes with factoring. If I have a polynomial and I factor it, okay, then I should, in theory, be able to multiply this back out and go back right where I started. It's a vicious cycle. All right, but if you do that, you clearly have to indicate that, hey, I'm checking my answer now at this point. This is the original binomial. I factored it to this. This is what the direction said. That's my answer. But if I want to check it, I'm going to take my answer that I got, which is the 2a, and then the 3a minus 4. All right, now, well, we learned yesterday how to multiply that, right? And or earlier, we distribute that 2a back into the problem. So that becomes a 6a squared, 2a times that negative 4 minus 8a. And then the question is, did I get what I started with? I did. It checks. So yes, this is the correct answer, correct factored answer. Okay, now I'm not going to make you show this on your paper. However, you're doing Math Excel, you do it really quick. You factor it and then just real quick multiply back out and see if you have it. And then you're going to know before you can put the answer in whether or not it's right. Okay, now let's do some more because that's just one example of that. All right, let's beef it up to more than just two terms. Okay, again, I'm going to write the directions here. Let's say it says factor. Okay. Let's suppose they give us a 9x to the third. Let's go back to x's. Minus a 6x squared plus a 12x. Okay, so this one happens to have three terms. That's okay. I'm going to take a look at the coefficients first. I have a 9, a 6, and a 12. So I need to ask myself, well, what's the biggest number, greatest common factor of those three numbers? Okay, so greatest common factor, I'm going to go ahead and list it out here specifically. All right, well, it looks to me like it's going to be 3, right? 3 goes in 9, 3 goes in 6, 3 goes in 12, so I definitely have a 3. Now I need to look at the variables. Okay, I have an x here, an x squared, and an x to the third. If we keep in mind I'm looking for the greatest common factor, then I'm going to pick the least one with the least exponent. All right, that's got an exponent of just 1 right there, so an x. So my greatest common factor is 3x. Okay, so like I said, Math Excel may ask you just that question. Here's a polynomial. Tell me what the greatest common factor is. Okay, now if it does, that would be one answer, but then the overall answer here, okay, now factor this polynomial. So I'm going to take that greatest common factor and I'm going to pull it out. All right, it'll always have a set of parentheses then because I'm undoing the distributive property. I'm going to divide it out of each of those terms. Since I have 3 in my original problem, I will have 3 in my answer. Okay, so I'm going to start dividing. 9 divided by 3 is 3. All right, I have x to the third. I have 3 x's. I'm taking 1 out. That means I have 2 left over. Okay, I'm pulling this stuff out. Okay, this is a negative, so I got -6 divided by 3 is going to give me a -2. So I divide out my coefficients. Then I take a look at my variables. I have 2 of them, 2 x's. I'm pulling 1 x out. I have 1 x left over. Okay, I've got a 12 here. I'm going to take this 12, divide out 3, which will leave me with a 4. I have 1 x. I'm taking it out, so that means this term will not have any x's left over at all. Okay, so this is my factored answer. All right, now if you want to check, you can check. All right, but if you're going to check, clearly indicate on your paper that you are checking. All right, like don't just take this and then keep working right below that. All right, because the direction said factor, this is where you stop. That's your answer. Okay, now if I want to check, I'm going to take the answer that I just got. And then I'm going to distribute it out, multiply it out, and see if I get the original problem. So I'm going to distribute that back in, see if I get it. Okay, 3 times 3 is going to be 9, x to the third. 3 times that, -2, minus 6, x squared. 3 times 4, 12, with the x. Okay, it checks with the original problem, so then that means I factored it. Okay, well, like I said, I'm not going to require that you do this. I would highly recommend it. You're more likely to get your answers right that way. All right, so that's kind of just taking out a greatest common factor. Okay, now let's go ahead because I want to implement this in with the trinomial with a leading coefficient of 1. I think I'm going to go to a whole new piece of paper and start over here. Okay, we're going to factor trinomials in more than one way here. We're going to factor, let's say factoring trinomials with coefficient 1. We're going to break them up. Okay, so that's why I wrote x squared plus bx plus c, just a little generic form indicating there that that coefficient is 1. All right, because we all know, you know, I'm letting b is just representing some random number. This is representing some random number, but what we're going to focus on today is just a leading coefficient of 1. All right, obviously we know that I could have a 3x squared plus a 5x plus 7. I could have something other than 1, but we're going to go at this kind of slow and do one thing at a time here. Now, again, especially since I think this is probably the first time you've seen this, I'm going to be very, very detailed and we're going to show a lot of work. Eventually, you're going to get to where you can factor these and you can go like really super fast. Okay, so let's take a look at, again, here, directions would have said factor. All right, I don't always write that down, but we know that's what we're doing here. All right, let's go with something that's got all plus signs. So let's go like x squared plus 7x plus 12. Okay, now, a trinomial is going to, if there is no greatest common factor, and I can look at this and I can see there is no greatest common factor. If I've got a trinomial, standard quadratic, as in x squared, an x term, and a constant, I know that this trinomial is going to factor into 2 binomials. All right, this is just a given. So I'm going to go ahead and I'm going to set up my problem like this. Okay, now think about what we did yesterday. If I had 2 binomials, what did we do? We FOILed it out. All right, like yesterday, if I had something like an x minus a 4 and then an x plus a 5. All right, well, what did we do? We FOILed, right? We multiplied, and factoring is undoing our multiplying. So when we multiplied this first term right here, what did we get? We got an x squared, right? So this is going to start my trinomial. So this is why when I FOIL this out, I get 3 terms. When I'm all done, I've combined like terms. So that's how I know this 3 terms are going to factor into 2 different binomials. Okay, now if this times this gave me the x squared, and I've got an x squared here and I'm trying to factor, then I know I have to have an x here and I have to have an x here. That's what makes factoring trinomials with a leading coefficient of 1 so easy. Okay, now I am going to show you the traditional chart method. All right, like a lot of textbooks will show you how to make a chart. I'm going to do this on the first one. All right, and then eventually, like I said, this is going to become natural for you. And so you're just going to do what's called a trial and error method. Okay, but until we learn that trial and error method, all right, whatever this number is right here, okay, that's going to be a 12. So I'm going to make a chart here, and I'm going to do my product has to equal 12. And then I'm going to take this middle number, and I'm going to say, okay, I need a sum of 7. Okay, it's always this. It's the two numbers that multiply together to equal 12, but then those same two numbers also have to add or sum to 7. All right, now, if you want to be very systematic in your trial and error, okay, you're going to write down all of your factors of 12 that multiply out to be 12. Okay, so in other words, a 1 times 12 is 12. We know that. Okay, 2 times 6 is 12. Okay, other factors, I've got 3 times 4. All right, if I list every one of my factors of 12, two things that multiply together to equal 12, then I'm going to find the right answer here. Okay, now what I'm going to do is I'm going to come over here and I'm going to sum these two numbers. So 12 and 1 is 13. 6 and 2 is 8. 4 and 3 is 7. All right, I'm looking for a sum of 7. That's what I'm looking for, okay, because I have a 7 right there. So I know 3 and 4 have to work. All right, this was all pluses everywhere. So if I put a +3 here and then I put a +4 there, I have factored it. Okay, I've essentially done trial and error, but yet I've organized my thinking. All right, now as you can see, hopefully, you know, especially when these numbers are really small, like real quickly in your head, you know 1 times 12, 2 times 6, 3 times 4. So you're thinking that, but at the same time, oh, 3 times 4, oh, I can get the 7. Okay, so you know, like I said, I'm not going to necessarily make you write this down. If it takes you to write this down to help organize your thinking, then you're more than welcome to do that. That is my factored form. That is the answer. Okay, now, again, we can do a check. All right, I haven't used green on this one yet, so every time you take a polynomial, no matter what it is, and you factor it, then you can turn around and check it to see if you did it right. So I'm going to take my answer, x plus 3, x plus 4. All right, and then what would I do? Multiply it back out because that's the inverse operation here. So I would do my first terms, x times x, going to give me an x squared. Then I would do my outside terms, x times 4 gives me a 4x. All right, 3 times x gives me those inside terms. I'm obviously showing all my steps. 3 times 4 is going to give me that 12. These two things are like terms. So I get the x squared, I get the 7x, and I get the 12, and it checks exactly with what I originally started with. Okay, so the main thing here is I have showed you the check on every problem we've done so far, and that's fine, but notice I'm doing it in a different color. I'm really trying to get you to understand this is not the answer. This is not part of the problem. This is you checking. All right. I have so many freshmen that come in here with, okay, here's my trinomial. I'm going to factor it. Then I'm immediately going to multiply back out and get right back here. And then they circle this as their final answer. That's what we started with. Okay. So you start with it, you factor it, you're done. That's your answer. If you want to check, you multiply it back out. Okay. All right, let's do another one because I don't have to have two plus signs. I could have two minus signs. I could have a minus sign, then a plus. I could have a plus and then a minus. Signs can be any way. All right, I'm going to go ahead and continue to do that chart again. All right, after we've done several of these, then maybe we'll switch up and get away from that a little bit. Okay, let me pull this back down, make sure it's in the video. Okay. All right, let's go with an x squared minus a 14x plus a 24. Okay, so trinomial. I've got an x squared term, an x term, and then a constant. So I know it's my basic trinomial with a leading coefficient of 1. So that means automatically, right off the top, I know this is going to factor into two binomials. So you get that set up. Since my leading term there is an x squared, I know I have an x and I have an x automatic on every one of these. Okay. Now let's go ahead and make our chart. All right. We need a product that equals what? The last number. And then we need a sum, all right, that equals, notice a negative. Okay, my sum has got to equal a negative 14. Okay, so I'm going to start listing. All right, now, again, there's going to be lots of factors of 24. And I am going to have to consider the signs. So after a while, can I throw some of these out? Like if I did 1 times 24, all right, well, when I add that, I automatically get a positive 25. But I know my sum has to be negative. So should I guess products that are both positive? No. All right, but if I need a positive 24, but yet a negative sum, I'm going to have two negative numbers right here. So stop and think about this. If I did negative 1 times a negative 24, negative 1 times negative 24 gives me the positive 24, which is what I need. That number is positive. All right, but when I add, then I get a negative 25, which is not the number I need, but at least it's negative. All right, so when I list my factors, don't take the time to list positive ones. Fit them the way you need them to be. All right, so let's just go up to 2, negative 2 times negative 12. Okay, that gives me the positive 24. If I add them, that gives me a negative 14. All right, so I got there really quickly, and I just did them in order. I did 1, then I did 2. Had that not worked, I would have went to 3 and then 4 until I found it. So as soon as you find it, then you're good. Now, what this tells you right here, both those numbers have to be negative. Okay, so when I put them in here, I'm not going to write plus. I'm going to write minus on both of them. So I'm going to write a minus 2 and a minus 12. Okay, and then I'm done. And as soon as if you use that little chart, it works out really, really nicely. Okay, now let's go back to a check here though, because I want to show you how this check's going to work. Okay, so x minus 2 times that x minus 12. Okay, so because you do have to make sure these signs match, like they're the way they need to be. All right, so if I FOIL this out, x times x gives me an x squared. Outside terms, minus 12x. Inside terms, minus 2x. Last terms, plus 24. Okay, putting these two together gives me that negative 14 in the middle. And I am showing like lots of work on this. Okay, we'll get to the place where we're doing more of this in our head. All right, so are we good so far? Okay, another question. Have you seen this before? Did you do this last year? Somebody's got to unmute your mic and tell me.
No, but that was really, really speedy.
Really, really speedy. Okay, I can slow down. So let's do it again with let's do it again and maybe try to do we like the chart? Do we like the chart?
Yes.
Yes, we like the chart. Okay. All right, more than one yes. We're just getting one yes.
Yeah, chart was good.
Okay,
Good.
chart's good.
Yeah.
All right. Okay, we'll keep using the chart then. All right, so let's do one where our chart's going to probably end up being a little bit bigger. Okay. All right, let's do an x squared plus a 7x minus a 60. All right, because we get some big numbers in here. Okay, that means I'm going to have a lot of factors to choose from. All right, and again, notice I can change up these signs any way I want. Okay, it is a trinomial. So I know it's going to factor into two binomials. All right, since this is an x squared, I know I'm going to have an x and an x, automatic. Every one of these are going to start up like this every time. Okay, all right, now let's come over here and do our product. All right, now this time our product has to equal negative 60. Okay, negative 60. And our sum has to equal the 7. So our sum has to equal 7. All right, now again, stop and think about this. If I am going to multiply two numbers, and it needs to be a negative, I'm going to have one negative and I'm going to have one positive, right? So the only way I can get a negative product, I have to have unlike signs. So every time I test my factors, I'm going to make one of them positive, one of them negative. All right. Now I do try to do this in a very systematic way, in the sense that I start with 1 times 60. All right. And then I go to 2, and then I go to 3, and then I go to 4, and then I go to 5. Now, when I list 1 times, let's say we'll make the 60 negative. Okay. That would be negative 60 times 1 gives me the negative 60. Okay. But now stop and think about this. If you really, really stop and think about this, when I add this, I get negative 59. I am really far away from 7. Okay, so technically, would I even need to try a negative 1 times a 60? Well, probably not. If I did, though, I mean, both of those are possibilities. But this time when I add this, I get a positive 59, okay, which, okay, I'm still really, really far away from that. All right, but just know that I've got to, in every set of factors, because it doesn't matter which one's negative there, all right, I've got to test both of them. Now, there again, if you want to eliminate some of your trials, this is a positive. If the bigger number has a negative, it's always going to be negative. So technically, I would only have to put the negative on the smaller number. Okay. All right. So do this systematically. Next thing I would try is like a negative 2 times a 30. All right. That's clearly negative 60. And again, notice I put the negative on the smaller number. All right. So when I add those two, I get a 28. So I'm getting closer to 7. Still not there yet. So then I'm going to go to a negative 3. Let's see, 3 goes into 60 20 times. Okay, so that multiplies to negative 60. Okay, but when I add, I get a 17. Again, notice these numbers are getting smaller, so I'm getting closer to 7. All right, let's see, 4 goes into 60, right? Negative 4 times, is that 15? Okay, so 15. Okay, and then let's see, when I add those, I get an 11. All right, so see, if I'm literally going to list every one of my trials, this can be a long process. Let's see, next number goes into 60 would be 5. Okay, so let's make it negative, and then 5 times 12. Now look, when I add, I get a positive 7. All right, if you list every one of your factors of 60 and you do it in a chart like that, you will find the answer. Okay, if the numbers are big, like 60, maybe you're going to want to use a chart. But if they're smaller, maybe you can find them in your head. Okay, and like I said, the more you do with this, the better and faster you're going to be. Now, obviously, when I put these two numbers in here, I have a negative 5, I have a positive 12. It does not matter which one I write first. Okay, generally, I just do whatever I happen to write down. So I put my minus 5 there, I'll put my plus 12 there. Okay, so then there is my factored answer. Okay. However, all right, let's do note, equivalent answer. And equivalent answer would be the x plus 12 written first, and then the x minus 5. All right, it doesn't matter the order because, right, we multiply any two numbers in any order or any three numbers, and I get the same answer. 2 times 3 is the exact same thing as 3 times 2. So this binomial times this binomial is the exact same thing as starting with this one and then multiplying by that. Okay, so they're equivalent answers. It doesn't matter which one of these you put where. All right, now let's go ahead and show the check just one more time. Okay. All right, and hopefully on the foil, like I'm actually literally writing the check out. You wouldn't necessarily have to do that. You ought to be able to check it in your head, multiply it out really quick, and then know that you've got it right. X times x is going to be x squared. All right, now can we do a little bit in our head here? Can I do 12 times x is 12x? Negative 5 times x is negative 5. So 12x minus 5 is 7x. All right, like 12 times negative 5, negative 60. Okay, like if you need to write down the first terms and then the outside terms and then the inside terms and then the last terms, that's fine. Okay, but anything that you can do to shorten it up to make it a little bit quicker, that's good. Okay, so that one was a longer one because that number was so big and we had to go through a lot of factors. Okay, now let's go back. I do want to try, because I want to try to, not that this is bad, you may use this, this is a good thing, but if you're capable of doing it without this, I definitely want you to try. Okay, so let's do like an x squared minus a 4x minus a 21. All right, at this point now, I think I've done every sign combination that we could encounter. I've got two negatives on this one. All right, again, looking at this, I've got an x squared, an x, and a constant term. Okay, I know it's going to factor into two binomials. So I'm going to set up my set of parentheses. I know that this first one, x squared, this is going to be an x, this is going to be an x. Okay, now without being as detailed in that chart, think of things that multiply together to be 21. All right, and technically I can ignore the signs to begin with if I'm really trying to do this quickly and in my head. All right, well, 1 times 21 is 21. 3 times 7 is 21. Okay, that's actually about it. All right, so, but just real quickly, doing that in my head, which one of those has to work? Well, it's got to be the 3 and 7 because that's the only way I'm going to get a 4. Honestly, with these two numbers, there's only two things we can do with those numbers. I either add them or I subtract them. All right, so when I'm listing, I don't have to have that great big detailed chart. I could list some factors here, real quickly take a look at these, add those numbers up, because that would be one possibility, subtract those numbers, subtracting the 3 and 7, get me that 4. I know I have to have a 3 and 7. And here again, I can put it wherever I want. If I'm doing this more along trial and error, I'm just going to randomly put 3 and 7 in there. It doesn't make any difference. Okay, now I've got to stop and think about, okay, well, how are my signs going to have to be? All right, I need a positive 21 when I multiply. I'm sorry, I'm looking at that wrong. I need a negative 21 when I multiply, but I need a negative 4 here when I add them. Okay, so in other words, I have to have unlike signs to get negative 21. So one of these has to be positive, one has to be negative. But when I add them, I need negative 4. So when I'm adding positive and negative numbers, what do? I add them up, I subtract and use the sign of the larger, which means the 7 is the one that's got to be the negative. The 3's got to be the positive one. All right, now, if that was a little too much, okay, possibility, let's go back. Let's do a little bit more detail here. My product needed to be a negative 21. My sum needed to be a negative 4. Okay, so what did I just use here? I used a positive 3 and a negative 7, okay, because clearly 3 times negative 7 is negative 21. When I add them, I get my sum of negative 4. And I'm just hoping that, like, you know, you can just maybe do this and do it in your head and then figure out where those signs go. Okay, and then of course we could check if we needed to. Now let's show you a check that's a little quicker check as opposed to what I was doing a minute ago. Okay. All right, a lot of times, just like if we wanted to speed this up. All right, so I know x times x is the x squared. I know 3 times negative 7 is negative 21. So I've got these two terms checked right away. Multiply these two for that, multiply these two for that. All right, now if I multiply here, I get a 3x. If I multiply here, I get a negative 7x. All right, well, what do I get when I add those? Negative 4x, and it matches my middle term. Okay, so a lot of people show work like that. All right, that way they're still foiling it out, they're still checking it, but they're just not doing the official FOIL that we'd done before. You multiply the first terms and you check there, you multiply the last terms and you check here. If I multiply the 2 inside, I multiply the 2 outside, and then I add real quick, I can real quickly check to see that that matches that middle term. And the deal is, it's got to match. Like when I multiply this back out, I have to get back to that original problem. Okay, is that a little bit better? Somebody at least give me a yes or a no.
Yeah.
A little bit better? Okay. Now, can I throw an extra letter in and not freak you out? I would like to be able to throw in an extra letter and not freak you out here. Okay. This is pretty much standard what you're going to see in Math Excel. They're going to throw in an extra letter, and that's okay. All right. So let's actually title this so that you'll know that this is a little bit different. Let's call this factoring a trinomial in 2 variables. Because I'm going to throw an extra letter. Okay. So let's try not to do too large a numbers. Let's do let's do like an x squared minus an 8xy plus a 15y squared. I have two variables in this one. Okay. And that's okay. It's still a trinomial. I still have a leading coefficient of 1. Okay, so that's good. The only difference is I've got an x squared here. I've got a y squared here. All right, and if you think about FOIL and that multiplying, if I've got an x in this term and I've got a y in this term, this middle term's got to be an xy. Okay, now it is a trinomial. So I know it's going to factor into two binomials. And with this having a leading coefficient of 1, I still know that that first one is x and x. Okay. So I know this has to be an x. I know this has to be an x. All right. Now, this last term, when I multiply the last terms, this whatever I put here times whatever I put here, I have to get a 15y squared. To get the y squared, the only way I can get a y squared there is if I have a y in both of those spots. All right, so I know I have to have a y here, and I know I have to have a y here. Now there's going to be coefficients because I need some numbers in here, okay? But I know that if I've got an x squared and a y squared, then I've got to have an x and a y and an x and a y, and I'm going to have some coefficients sitting right in here, okay? Now, again, if we wanted to try, let's try to do it both ways. Let's try to kind of do this in our head, all right? And then I'll make the nice, neat little chart, okay? Okay, so if I'm thinking of things that multiply together to equal 15, okay, well, we know 1 times 15, right? And we know 3 times 5. All right, well, okay, as soon as I see 3 and 5, I can get an 8 from a 3 and a 5. Okay, so hopefully, you know, that's what I'm saying. Hopefully we can just kind of look at that. So I know right now, just from that, I've listing my things that multiply together to be 15. And as soon as I get a pair that add to that middle number or subtract to that middle number, I know those have to be it. So I'm going to have a 5 and a 3. I know that right off the bat. Okay. Now, let's go ahead and make the chart here just for those people that are liking the chart. All right. Let's say I have a product and it's got to equal my positive 15. And my sum, it has to equal a negative 8. Okay, so again, I'm going to list those. I need now, if I list a 1 times a 15, and then when I go to add those, I get a 16, I'm never going to get a negative number, right? So when I do my products to get a positive 15, the only way I'm going to get a negative sum is if they're both negative. Okay, so in other words, a negative 1 times a negative 15 still gives me the positive 15. But when I add, I get the negative 16. Okay, so we don't want to try any of them that's just positive. They both, this tells me they both have to be negative. So, all right, so let's just jump to the one that we know that's got to work. All right, a negative 3 times a negative 5. Negative times negative there is going to give me that positive 15. When I add them, all right, I get the negative 8, which is what I want, which tells me both of those have to be negative then. Okay, so negative 3 and negative 5. And again, I could have put the 5 first. I could have put the 3 first. It doesn't make any difference. All right, since we have, and then that's my answer. I have factored that trinomial. Okay, now let's go ahead and do a check. All right, I'm going to go back to the more traditional check on this one, just showing some more steps. All right, so I'm going to take that answer. I'm going to do an x minus a 3y times an x minus a 5y. That was my answer. Okay, I'm going to FOIL it out. Okay, when I check, all I am doing is foiling when I check. So x times x gives me an x squared. I'm going to show all my work on this one. If I multiply my outside terms, a negative 5y and x is going to give me a negative 5xy. If I multiply inside terms, okay, putting them in alphabetical order, a minus 3xy. If I multiply my last terms, negative times negative is going to give me a positive 15, and 2 y's there will give me a y squared. All right, putting these two together, all right, x squared. These are like terms, so minus 8xy, and the last term down there, 15y squared. Okay, so it does check, all right, it checks. This is the answer to the problem because the directions would have said factor or factor completely. Okay. All right, so how'd that one go? Get a little bit of feedback there? Makes sense?
Yeah.
Okay, about the only new thing on this, I mean, if that y squared wasn't there, it's exactly like the first however many examples we just did. Throwing a y squared in here just puts a y there and there. So you do it the same way, you throw that y in there. Okay. All right. I don't know how many of those you will have to do. I honestly do not know how many you're going to have to do of those. Okay. Now, at some point, the directions are going to say more than just factor. They're going to say factor completely. And what we're going to do is we go through this chapter. Every time I teach you something, it's just going to build. Okay, as is with math has this whole time. I teach you one concept, then we go to the next one. All right, and then I go to the next one. And then by the time we've got 3 concepts, I might have to use all 3 concepts to answer a problem. And factoring definitely works that way. Okay, so we're gonna go ahead and introduce this to you once, and we may have to talk about it way more than one time. All right, but this is going to be factoring completely. Now, at this point, after what we have talked about today, you have basically 2 factoring techniques under your belt, okay? You know how to take out a greatest common factor, and you know how to factor a trinomial with leading coefficient of 1, okay? Those are the 2 things that we have done today, okay? 2 major concepts. So at this point, if I'm going to factor completely, I could give you a problem that requires you to do the greatest common factor first, and then factor the trinomial. Okay, so you've got to do 2 steps to actually get to your answer. Okay, so I'll do at least a couple of these. All right, let's suppose we had an 8, x to the 3rd minus a 40, x squared minus 48x. All right, nice little trinomial there. Not necessarily in quadratic form. I have an x to the 3rd, I've got an x squared here, I've got an x. Okay, and the directions are telling me factor completely. So we're going to ultimately, by the end of the chapter, I'm going to give you like a little factor tree guide that's going to say, okay, you should always look for that greatest common factor first, and then you should try this, and then you should try this, and then you should try this. So right now, since these are the 2 things that we have to do, you're always going to check for that greatest common factor first. Okay. So going back to what we did at the very, very beginning, I'm going to look for a GCF. Okay, so I'm going to take a look at the 8 and the 40 and the 48. I'm going to try to find the biggest number that goes into all of them. So what's that going to be? Let's see, 8 goes into 8, 8 goes into 40, 8 goes into 48. So it's 8, right? If I make a mistake on my greatest common factor, somebody yell at me. Okay, and then at the very beginning, we were looking at the variables as well. And we said the little trick was if it was greatest common factor, then it would be the least exponent. Well, my smallest exponent on my x there is an x to the 1st. So 8x is going to be the GCF, the greatest common factor. Okay, so that's going to be my first factoring thing I'm going to do. I'm going to take that 8x out. All right, now going back to when we started this lesson. Okay, this has 3 terms. Okay, so if I had 3 terms, this is me undoing the distributive property, what we did at the very beginning. I'm going to have 3 terms on the inside. So I'm dividing this greatest common factor out. 8 divided by 8 gives me 1. I had 3 x's. I take one of them out. I have an x squared left on the inside. Now I'm going to take the 8x out of the middle term. Negative 40 divided by 8. All right, negative 5. All right, I have 2 x's. I'm taking 1 out. That means I have 1 left over. All right, negative 48. Divide out the 8 should leave me with minus 6. All right, I had 1x. I took the x out, so this term does not have any x's left over. All right, so from here to here, from this step to this step, I took out the greatest common factor. Okay, so that was my first factoring technique. All right, now what I'm going to do, since it says factor completely, I have to look and see what I've got left. I've got a greatest common factor, and I've got a trinomial on the inside. A trinomial that is in quadratic form because this is x squared, this is a plain x, this is a number. And I've got that imaginary, leading coefficient of 1, so it's this now. So now I can factor this. The only thing I'm going to factor, I'm going to focus on just this inside part and factor it just like my trinomials. This remains part of my answer, okay? So just like when we solve equations or we're adding like terms and we don't use something, we bring it down, okay? So this greatest common factor come straight down on my next line of work. All right, I know that a trinomial factors into two binomials. So then I'm going to set it up for that. I know that since this has a leading coefficient of 1, this is going to be x and x. So I'm going to have an x here. I'm going to have an x here. All right. And now, again, let's try to do this a little bit shortcut here. Okay. All right. Let's do this. So things that multiply together to be 6. Okay. 1 times 6 and 2 times 3. Those are my only choices, right? Now, on this one, you are going to have to do a little bit of, well, a little more trial and error on this, because if I subtract 1 and 6, I can get a 5. If I add 2 and 3, I can get a 5. All right, so this one, I can see how maybe you might want to do a table, definitely, for this one. So let's go ahead and go back to our table, since, you know, this is kind of a little foggy for some of you maybe. So let's do, I need a product that's going to equal a -6. I need a sum that's going to equal a -5. All right, so what's that tell me? Let's see. If I need a negative product, one of them's got to be positive, one of them's got to be negative. Okay, so well, right there, that kind of rules out then this second one here. But if you don't see that yet, okay, one of them's got to be positive, one's got to be negative. So if I made it a -6, or I'm sorry, -1 and a +6, so when I add there, I get a +5. That's not going to work. Okay, if I switch it around, if I do 1 times a -6, and then I add, there's my -5. Okay, and so knowing that this was a negative kind of like ruled this out, because one of them would have to be positive, one of them have to be negative. I'm going to subtract every time. I would get a 1. That's not going to work. Okay, so then that meant this is what works. And again, it does not matter if I put +1 here or a -6 here. Does not matter. Okay, so let's just do it in the order that we've got: a +1 and a -6. Okay, this is my final factored answer. It has been factored completely. From this step to this step, I factored using my trinomial. Okay, just kind of showing there my guess and check, factoring that trinomial. So this is taking both of the skills that I've taught you separately and putting them together in one problem. Take out the greatest common factor first, and then factor with the trinomial second. Okay. Now, technically, I can check this. All right, let's see how we doing on time. It's only 2:20. Let's go ahead and check this one. All right, because there is, you need to, if you're going to check these, you definitely need to do it in the right order. Okay, so let's take the answer that I got: 8x, x plus 1, x minus 6. All right, now what I would do first is I would literally go backwards in exactly the way that I did that first. The first thing I would do is I would FOIL this out. Okay, so FOIL that out first. Keep that 8x right there. All right, so if I factor here, if I FOIL out, I'm going to have x times x, which is x squared. If I do my outside terms, I'll have a -6x. If I do the inside terms, I'll have a plus x. If I do my last terms, I'll have a -6. All right, that'd be an 8x right there. Combining those terms in the middle, x squared minus 5x minus 6. Okay, now last step, I'm still multiplying, right? Last step then would be to distribute that back into that. So 8x to the third minus 40x squared minus 48x. And then coming back up here, does it match what I started with? And the answer is yes, it does. It checks. Okay. All right, so this is what we are going to do this entire chapter. I'm going to teach you a factoring skill, and then we'll do them individually. So you'll do several where you just have to take out the greatest common factor. We'll do several where you just have to factor your trinomial, and then we will start putting them together, and you will use 2 at a time, or 3 at a time, or 4 at a time. All right, let's do one more like that, and then maybe we'll call it quits, okay? So let's start with a 3x to the third minus a 15x squared minus a 42x. All right, again, I didn't write this down, but always, all right, we're doing the exact same thing we did a minute ago, and this time it's going to say factor completely. That means you got to keep going and keep factoring until it cannot be factored anymore. Okay, so the first thing I'm going to do, again, since we only have 2 things, we know greatest common factor, we know how to factor a trinomial with leading coefficient 1. So I'm going to look for that greatest common factor first. So I'm going to take a look at those coefficients. 3, 15, and 42. Okay, so 3 goes into 15, 3 goes into 42. That's going to be about it. 3 goes into 3, so 3. All right, then I'm going to take a look at all my x terms. I have an x to the first. I have an x squared and x to the third. So it should just be a plain x, right? Lowest exponent. So in my first step, I'm taking out a 3x. I'm going to take out that 3x. Okay, so I'm going to divide it out of each term. So 3 divided by 3 is 1. I have 3 x's. I take 1 out. I have 2 left over. Negative 15 divided by 3. It's going to be a negative 5. I have 2 x's. I take 1 x out. I have an x left over. Okay. Negative 42 divided by 3 is going to be negative 14. I have an x. I take 1 x out. I don't have any x's left over. So I'm down to my trinomial on the inside. All right. I can look at that. I can know then that this is a trinomial and it's probably going to factor. Okay. So I'm going to factor that. I have to keep my greatest common factor on the outside so it stays right there. Okay. I've got a trinomial. Okay. I know it's going to factor into 2 binomials. So I'm going to set it up for that. Since this is a leading coefficient of 1, I'm going to have an x and an x. All right. Now, hopefully this one may be hopefully a little bit easier here. Let's try to do this one a little bit quicker on our chart here. Factors of 14. If I do a 1 times a 14, I'm not going to get a 5. Let's do 2 times 7. 2 times 7 is 14, and I'm going to get a 5 here. All right, now stop and think about this. I need a negative 5, okay? So the only way I can get a 5 would be to subtract. The only way I could subtract would if one of them's positive, one of them's negative, and I want my 5 to be negative. So I've got to have a negative 7 and a positive 2. Okay, if you do a little bit of thinking here, this should work out. If I multiply these two, I get negative 14. If I add these two, I get negative 5. Okay, had I tried it the other way around, negative 2 and 7, well, multiplying would have been fine, but then when I add these two, that would have given me what? A positive 5, and that's not the middle term. Okay, so that wouldn't have worked. Okay, so you can do some of that without that official chart, I'm hoping. Okay, so we've decided that I've got to have a negative 7 and a positive 2. Okay, so a positive 2 and a minus 7. And then now I'm done. All right, if I want to check, I can check at this point. All right, and maybe on this very first assignment where we're doing this, might be a good idea if you check every time. Okay, we'll go ahead and do a check on this last problem. Okay, just to make sure that we know, because when we're checking these, you really do need to FOIL first and then distribute. All right, so if I have the 3x, I have an x plus a 2, I have an x minus a 7. All right, so the first thing I want to do is I want to FOIL this part right here. That's going to be my first step when in my check. Okay, so I'm going to keep my 3x right there. Multiplying first terms, x times x will give me an x squared. Multiplying outside terms will give me a minus 7x. Multiplying inside terms, plus 2x. Multiplying last terms, minus 14. All right, putting these two together right there, I'm going to have a 3x here. My x squared, go ahead and add these like terms. I'm going to have that minus 5x, minus 14. The last part of my check would be to distribute that back into the problem. So a 3x to the third. All right, negative 15, x squared. 3 times that negative 14 is going to be that negative 42x. Okay, again, check with what you had originally. All right, and it checks. Okay. All right. So 2 concepts. All right, but 2 concepts that go together, and there is a time and place where we've got to be able to do more than one thing at a time. All right, one interlocks with the other one when we are doing this. I'm going to go ahead and at this point stop.